Good afternoon, everybody. Welcome back. I hope that you had a nice long weekend. Today what we're looking at is lesson 30.08, which is on trigonometric proofs, which can be found on page 2 of the second part of the rest of the story, which was a new handout available to you yesterday. We're looking at proving identities today, and I've come up with 4 different examples that we're going to do. If at the end of the example you feel you need additional instruction, then there are examples in your textbook that I refer to here which are similar to the ones that we're doing as a group. So what does it mean to say we're going to prove an identity? What it means is that we have to work on the left-hand side separate from the right-hand side, and the right-hand side separate from the left-hand side, so that I can show that they are equal. Okay, so prove the identity tan of x cos of x over cosecant of x is equal to 1 minus cos squared. There's a very, very specific process that we need to follow here. And the first step is to rewrite the identity without the equal sign. And what you're going to do is you're going to write what the left-hand side, LS stands for left-hand side, is equal to. It's tan x cos x over cosecant of x. Then in another column, you're going to write what the right-hand side is equal to, which is 1 minus cosine squared of x. And you're going to leave a bit of room in each column to write down a few things. Now, what does it mean to say we're going to prove this? We have to demonstrate that tan of x times cos of x over cosecant of x and that 1 minus cos squared of x are the same. We are going to do that by continually changing the appearance of the left side and the appearance of the right side using identities from your formula sheet. So that's one of the first things to note is as we go through our work today, you are going to need a formula sheet that you can refer to so that you can look at the identities. The idea here is to use known identities to change the appearance of what we're looking at on either side so that things get simpler. And ultimately, if the left-hand side can be simplified to one particular thing, and the right-hand side can be simplified to that same particular thing, then we will have shown that the left and the right-hand sides are equal. As an illustration, when we take a look at the right-hand side, we know that sine squared of x plus cos squared of x is equal to 1. And over here on the right-hand side, I have 1 minus cos squared. Well, if I subtract cos squared, I get sine squared of x equals 1 minus cos squared of x. And that means that 1 minus cos squared of x in my right-hand column can be rewritten as sine squared of x. And sine squared of x is simpler than 1 minus cos squared. And to be perfectly honest, I don't know that I can really simplify sine squared of x any further. There's not much I can do with it. On the left-hand side, what I want to do is rewrite everything in terms of sines and cosines. These are the tips that I gave you in working with trigonometric expressions a few lessons ago. So one of the things that I know by looking at my formula sheet, and I'm not going to be flipping back and forth to my formula sheet, but you may have to pause the video and do that. One of the things I know is that tangent of an angle is equal to sine of an angle over cosine of an angle. And another thing that I know is cosecant of an angle is equal to 1 over sine of an angle. And I'm going to use those 2 pieces of information to rewrite what I have in the left-hand side column. I have tan of x times cos of x, so that's sine of x over cosine of x, that's my tan of x, multiplied by the cosine of x that's also on the top, and then it's divided by 1 over sine of x. And now I can do a little bit of algebra. I notice that on the top, I can cancel this cosine of x with this cosine of x. What does that leave me with? On the top, a single sine of x, and on the bottom, 1 over sine of x. Notice, by the way, I'm always working down. I'm never working left to right here. There's one more thing I can do here. When I have sine of x divided by 1 over sine of x, I can multiply by the reciprocal because that's how we divide by a fraction. And then I have sine of x times sine of x, which is sine squared of x. But if I were to go back to where we left off on the right-hand side, the right-hand side we have already shown is equal to sine squared of x. So what we have shown is that the left side equals the right side, and we're done. So that's the first example. Example 2 asks us to prove this identity on the left-hand side. We have sine of 2x over cosine of 2x plus 1. And on the right-hand side, we have tan of x. And since the right-hand side is really quite simple, my goal here is not going to be to try to turn tan of x into that beast on the left. What I'm going to do is use all of my skills to see if I can turn the left-hand side into tan of x. Now, there are some things that I know from my formula sheet. And again, I'm not going to pull them up here. You should be actively taking a look at your formula sheet and finding this out for yourself. I have on the formula sheet sine of 2x equals 2 sine x cos x. And I'm going to replace the sine of 2x on the left-hand side with 2 sine of x cosine of x. And then on the bottom, I have to replace the cos of 2x with something. So I'm going to have cos of 2x, then I will have plus 1. Now you need to do a little bit of digging and a little bit of thinking. Cosine of 2x is equal to cos squared of x minus sine squared of x. Or it's also equal to 1 minus 2 sine squared of x, but it's also equal to 2 cos squared of x minus 1. And you have to ask yourselves which of these three I'm going to put down here. Which of those three substitutions would be the wisest move? So for example, what would happen if I put cos squared minus sine squared in that set of brackets on the bottom? What would happen if I put 1 minus 2 sine squared in that set of brackets? What would happen if I put 2 cos squared minus 1? Well, I won't bore you with showing all of the substitutions, but if I put cos squared x minus sine squared x down there, I'm going to have a mess. I'm going to have cos squared x minus sine squared x plus 1, and that doesn't really help me. It doesn't become simpler. Similarly, if I put 1 minus 2 sine squared in there, it would become more complicated. My goal is to try to simplify things. So if I put down here in the brackets 2 cos squared x minus 1, an interesting thing happens. And that's that on the bottom you have 2 cos squared x minus 1 plus 1. Negative 1 plus 1 is 0, which means we have 2 sine x cos x on the top. And on the bottom we have 2 cos squared of x. So how can we simplify that? Well, I'm going to rewrite this as 2 times sine of x times cosine of x. And then on the bottom, I'm going to write 2 times cos of x times cos of x. Just to show you that what we can do is cancel the 2's, cancel a cos, and we are left with sine x over cos x. But if we take a look at what the right-hand side is equal to, don't forget the right-hand side is equal to tangent of x. And what we have on the left-hand side is sine of x over cos of x. But you know from your formula sheet that tan of x is sine of x over cos of x. So I can just write tan of x now on the left, and then I can say that the left-hand side and the right-hand side are equal to each other. And I'm done. That's the proof. All right, let's take a look at example 3. Example 3 is probably the sneakiest of them. On the left-hand side, we have 1 divided by sine of x plus 1. And on the right-hand side, we have secant of x minus sine of x multiplied by secant of x all over cosine of x. And there's not a lot I can do with the left-hand side, but I do see reciprocal trigonometric ratios on the right side. Specifically, I'm seeing secant of x, and I know that secant of x is the reciprocal of cosine of x. So I'm going to rewrite the right-hand side, but every place I see a secant of x, I'm going to replace it with 1 minus cosine of x. So on the top I have secant of x, which is 1 over cosine of x, minus sine of x multiplied by secant of x, which is 1 over cosine of x. And this entire thing is over cosine of x. And what I've created is what we call in math a complex fraction. It's called a complex fraction because even though it is one large fraction, it contains within it little tiny fractions. Specifically, these two denominators in the numerator are unwanted. I would like to get rid of them. And the most efficient way to do so would be to multiply the entire top and the entire bottom, in this case by cosine of x. If I do that, then when I multiply cosine of x into the numerator, the cosines will cancel. So I need to multiply cosine of x times 1 over cosine of x, which is going to give me 1. Minus, I need to multiply the cosine of x by sine of x times 1 over cosine of x. The cosines will cancel. I have sine of x, and then it's over cosine squared of x. And don't forget that the left-hand side, I'll rewrite it here so we can see it, is 1 over sine of x plus 1. And how is it we go about making these equal to each other? Well, this is the thing that makes this very tricky. So I'm going to take a detour from this for a second and talk about something else. Specifically, I want to have a conversation with you about this identity that is what some would say the most famous trigonometric identity. It's one that everybody remembers. Sine squared of x plus cos squared of x equals 1. We've already talked about the fact that you have to keep your eyes peeled for this. Because if I subtract sine squared of x from both sides, I would get 1 minus sine squared of x equals cosine squared of x. I've also talked about the fact that you should keep your eyes peeled for this. But one of the things I want to talk about now, and we'll use the top one, is that 1 minus sine squared of x is a difference of squares. This can be factored. It can be factored into 1 plus sine of x 1 minus sine of x. So that means that cosine squared of x could be written as 1 minus sine squared of x, which in turn could be written as this factored expression. Similarly, and I forgot my squared on the sign over here, I could factor 1 minus cos squared into 1 plus cos of x, 1 minus cos of x, and that's equal to sine squared of x. And this is the approach we're going to take with this question. And this is going to require a bit of practice. It's not going to come easy for most of you. It will take time. When I take a look at the bottom here, I see a cos squared of x, and I see 1 minus sine of x on the top. And I also see over here on the left-hand side, sine of x plus 1. Something is telling me that I should take that cos squared of x and write it as 1 minus sine squared of x so that I can factor it. And some of you will already be seeing what's going to happen here. If I factor that denominator, I'm going to have 1 minus sine of x on the top, and on the bottom I will have 1 plus sine of x, 1 minus sine of x, and the 1 minus sine of x cancels, and I'm left with 1 on the top over 1 plus sine of x. And that's what the left-hand side is equal to. It's equal to 1 over sine x plus 1. Sine x plus 1 and 1 plus sine x are essentially the same thing. So we've proved this identity. All right, let's take a look at example 4. It looks like a really tough question, but it turns out it's not. The left-hand side and the right-hand side need to be rewritten. So we have sine of 2x minus cosine of x over 4 sine squared x minus 1. And then on the right-hand side, I have sine squared of x cosine of x plus cosine cubed of x, and it's over 2 sine x plus 1. So what can we do? Well, on the left-hand side, we have a double angle. We have sine of 2x. Well, sine of 2x is the same as 2 sine x cos x. So I'm going to replace sine of 2x with 2 sine x cos x. Let's see what we get. I will have 2 sine x cos x minus cos x over, now we have to always be looking forward. Over here on the right-hand side, this is my eyeball, I notice there is a 2 sine x plus 1. And on the left-hand side, I notice there is a difference of squares. 4 sine squared x minus 1 factors into 2 sine x plus 1, 2 sine x minus 1. So I think that's something we should pursue. Let's continue to work with the left-hand side. In the numerator of the left-hand side, I can factor cosine of x out. If I factor a cosine of x out, I have left 2 sine of x minus 1, and it's over 2 sine of x plus 1, 2 sine of x minus 1. The 2 sine of x minus 1's cancel, so we're left with cosine of x over 2 sine of x plus 1. Well, that's looking pretty good because on the right-hand side we have 2 sine of x plus 1 in the denominator. So let's continue to work with the right-hand side. I can factor out a cosine of x out of the top. And what would I have left? I would have sine squared of x plus cos squared of x. and this is over 2 sine of x plus 1, everybody should recognize that sine squared of x plus cosine squared of x is equal to 1. Which means that the right-hand side is equal to cosine of x on the top times 1, but I don't think we need to write times 1, over 2 sine of x plus 1. And we're done, because now we can say that the left-hand side and the right-hand side are equal. If you go to your classroom folder, you will find a file in there. It's a one-page PDF file. It's called Trig Proofs Help. And on this single page, I've typed out for you all of the things that are useful suggestions in trying to prove identities. They are all things we've talked about in the lessons that we did prior to this, and we talked about them in this lesson as well. But it's not a bad idea to refer to this. So I might even suggest, as well as when you're working on your identity proofs today, as well as having a formula sheet handy, print this little sheet out and you can refer to it as well. On page 315, questions 7, 11, and 12 are good questions to get practice with proving identities. Remember, when you prove an identity, you're working on the left side and you're working on the right side separate from one another. You're trying to get them to be equal to each other. So I hope you have a great rest of the day. Good luck with these problems. Remember that tomorrow you can come into the Google Meet during our period 3 class and ask any questions, and I would be happy to help you out then. Have a great rest of the day, you guys. We'll talk to you later.